Welcome to this video. So in this video, we're going to look at the Dijkstra's algorithm. It is one of the most powerful algorithms that we use to find the shortest path between nodes in a graph. The reason why it is important is because it's used in a number of services that we do use on a day-to-day basis. So we talk of Google Maps, delivery services, and GPS systems. And they're used in these systems basically to determine the quickest or the shortest route. So we're going to learn the logic behind the Dijkstra's algorithm, how it works step by step, and how we can code it ourselves later on. So the Dijkstra's algorithm, first, to understand what it is an algorithm that finds the shortest path from the start of a node to all other nodes in a weighted graph. So an example is what we have here. This is a weighted graph. As, as you can see, there are all these nodes, and on the edges, each of the edges has a value that is already attached to it. And that's so basically the Dijkstra's algorithm is going to help us find the shortest path from a start node to all the other nodes that we have in our graph. Now, the reason why we need to look into this, or rather, why we need to understand how it works, so that it's easier for us to understand the logic later on. So, for a weighted graph, it's basically that in every connection, rather, that is now the edges, there's a certain cost or a weight that is attached to it. So the cost could be in form of distance, time, the fuel costs, and a few others. An example of a real world use case of such an algorithm is, for example, in Google Maps, when you ask for the shortest route between two places, the app is going to run a version of a Dijkstra's algorithm behind the scenes. So basically, it's going to check the nodes. In this case, the nodes are going to be at the locations, which could be cities or intersections in a place where you are trying to get to. Then edges, we talk of now edges, which are what we refer to these ones here. This is going to be the distance between the roads that are between your distances or certain connections. The weights are going to represent now the travel time, the distance between those two the places you're going to, and also the traffic level along those routes. Now, how the Dijkstra's algorithm works is basically the first thing you do is we initialize all the distances to infinity except the starting node. So basically, imagine you're starting from city A. So let's say this is our city A here, and we want to find the shortest path to every other city that exists in our graph here. So we assume an infinite distance to every other city initially, and the reason we do that is because we don't know the actual paths that are going to follow yet. So we basically set the distance to the start node. In this case, node A, we set the distance to 0, like that. Then the next thing we're going to do is use a priority queue or a minimum heap, a mini heap, that is, to explore the shortest path first. So what the queue is going to do, it's going to always pick the smallest distance first. It's like basically checking the nearest city to explore. So an example here, we have city B and we have city C here. As you can see, city A to B, this is the smallest distance. So assuming this was the weight here, this was the distance. And then now for each explored node, for each node that we explore, we're going to go ahead and update the distance that is there to its neighbors. So if the new path to a neighbor is shorter than what we knew before, we basically update we update the shortest distance. So for example, if we're trying to get to C, as you can see, if we check this node here, that we see the distance is 3. Initially it was 4. Then we just update that. Then we're going to repeat that process until all the nodes that exist have been visited. So this is we're going to use this graph that is here to just understand what it all does. Each city, as you can see, A, B, C, D is a node. Then we have all these weights that are in between. So we're going to find the shortest path from A, like you've mentioned, to all the other nodes. So the first step, like you've mentioned, we set the distance here to 0. Then we start exploring other nodes. So if you're moving, let's say from A to B, here the distance is 1, right? And then A to C, the distance is 4. So we are basically add B and C to the to a priority queue. So we form a priority queue, then we add B and C. Then from there, the next step we're going to go ahead and do is basically pop B from the queue that we have, which is again that's the smallest distance of 1. Then explore the neighbors that B has. So as we pop B from the queue, we're going to explore the neighbors of B. So this is our B here, and its neighbors, as you can see, we have D, we have C, we still have A as well. But we're going to focus on C. So, and we see the distance from B to C here is 2. So now the total distance to get to C from point A, which was our starting node, is going to be 1 plus 2. Then finally, it's going to be 3 in total. Then we also explore B to D. So if you check B to D here, it has a distance of 5. And also we update the distance. So this is going to be 1 plus 5, then we find 6. So in this case, we're going to update the distance that C with C, where we have the total distance here to be 3, because that is the shortest path that we have so far. Then after that, we're going to go ahead and pop C from the queue that we have. And then again, the reason we're doing this is because its smallest distance is 3. We're also going to explore the neighbors of C, and in this case it's D, right? So as you can, from C to D has this is a distance of 1. We have now 3 plus 1, then finally we end up with 4, which is going to be the updated distance. So and then after that, we pop D out of from the queue rather, and there are going to be no more neighbors to explore from this point. So as you can see now, from A, if you were to get from A to D, we've gotten our shortest distance, our shortest path, which is from going from A to B to C, then to D, like that. It has a total distance of 4, but if you look at the other ones, the distance are quite a large number. And that is in a nutshell what the Dijkstra's algorithm is. So next we're going to look at Python implementation of this, and we'll do that in the next video.